What is up, Precalculus students? This is lesson 85. Our objective is how do you find the determinant of a 3x3 matrix, and then how do you use them to solve a system. So just recall real quick, when we're working with the determinant of a 2x2, remember we can only find the determinant of a square matrix, we can say this times this minus this times this, AD minus BC. To do a 3x3 matrix gets a little bit more complicated, and by a little bit I mean a lot. It's kind of helpful to rewrite these first two columns right outside. Notice this is A1, A2, A3, B1, B2, B3, so that's just this column and that column rewritten outside. And so you do this main diagonal going down, you find the product of this times this times this, then you add the product of this times this times this, add the product of this times this times this. That's this, this, and this. Then you subtract the product of this times this times this, plus this times this times this, plus this times this times this. 1, 2, 3. So it's this first one minus the second one. And if you notice, if you kind of take this pattern and go back to this one, you see, oh yeah, it does follow that pattern so that all of them are used, right? And this A2 is used right here, right? And this B2 is used right there. So they are all used. So it gets a little bit more complicated, but it's not hard. It's just, can you remember it? So let's try one here. So we're going to rewrite this out here. Here we go. -3. -1, -1, that's just this column I rewrote. And this next one is going to be -3, 5, -4. So, let's go with the down angle ones first. I'm going to find the product of these three numbers, then of these three numbers, and then of these three numbers. I am using a calculator to do this, so don't just think I'm doing this all in my head. I am saying 9 times 5. I guess maybe I can do some of this in my head. So 9 times 5 is 45, and there's just one negative sign, this will be minus. 3 times 0 times -1 is going to be 0, so it's going to be plus 0. 4 times 4 is 16 times 1, so it's going to come out to be a positive 16, plus 16. The product of these three came out to be -45. The product of these three came out to be 0. The product of these three came out to be 16. Then I'm going to do this product, and this product. I'm going to say minus 5 times 1 times 4, so it's going to be -20. Plus 0, because this one comes out to be -20, this one comes out to be 0. 3 plus 9. It's 3 times -1. Simplifying that down, it's going to be -29 minus and minus 11. So -29 plus 11 comes out to be -18. So the determinant of number 1 there is -18. Now, remember Cramer's rule? Cramer's rule is where we had a system of equations like this, where that A, B, C, and D were numbers, and then that's X, Y, and then these are numbers over here. So we'd find out this determinant down here, so that's technically the determinant of these, where it just has all four of those. And then if you're looking for X, then you would replace these with your X coefficients. And when you're looking for Y, you would replace these with your Y coefficients. Okay? And so the same rule kind of applies, except for now we're going to have 3 variables, because the system of equations would have, X, Y, and Z. And so the denominator, this D down here, is just going to be what we call the coefficient matrix. All these coefficients. D sub x is going to be the one for the numerator right here when I'm solving for x. And so all these variables right here are the coefficients of x. I'd replace with these, they're labeling them as d's, right, my constants over here. And then whenever I'm looking for y's, I'm going to replace my y coefficients with these. See right here, y coefficients with these. Whenever I'm looking for z's, I replace it with these z coefficients right there. Also, something else to note, remember, if d is 0, if that denominator is 0, that means you either have infinitely many solutions or no solutions. If all of the numerator matrix, so this one, and this one, combine to be 0, then that's when you'd say infinite number of solutions. If any one of these comes out to be a number, then you would say no solutions if one of those numerator matrix is not 0. So any number besides 0, then you would say no solutions. Alright, so here we go. Let's go ahead and set up that D for the denominator matrix. That's going to be, so I'm just going to pretend like I have an X, a Y, and a Z. So this is going to be the determinant of 5, 0, negative 2, 0, negative 4, negative 4, 5, 1, 1. Find the determinant. I'm going to rewrite these out here. 5, 0, 5, 0, negative 4, 1. The more zeros there, it actually comes out to be a little bit nicer, right? So multiply these three. Add to that the product of these three. Add to that the product of these three, which is a nice easy one here. Then a subtract this, which comes out to be negative 20. This, which is 0. And this, which is 0. It's going to be 20 minus a minus 20, which is plus 20, so this comes out to be 40. So then now I need to find my d sub x, my d sub y, my d sub z. Remember, that means my x column. So it's going to look pretty similar to this one, right? Except for I'm going to be replacing different columns. So this is going to be 13, 8, 3, 0, negative 4, 1, negative 2, negative 4, 1. This one is going to be 5, 0, 5, 13, 8, 3, negative 2, negative 4, 1. This one is going to be 5, 0, 5, 0, negative 4, 1, 13, 8, 3. I'm going to pause the video and calculate these, and that's just to save you watching me painstakingly calculate these. Feel free to check my work, but I think this is coming out right. Make sure you can do this on your own. I just don't want to force you to watch that. So x is going to equal to dx over d, which is going to be 40 over 40, which is equal to 1. Y is going to equal to dy over d, which is going to equal to 80 over 40, which is going to equal to 2. And z is equal to dz over d, which is going to equal to negative 160 over 40, which comes out to be negative 4. So my answer, if I'm going to put it as an ordered triplet, would just be 1, 2, negative 4. Alright, so let's try one more. And just so you know, when I'm finished with this, I'll be halfway done with your homework. So you only have the other half to do. So you should at least get a 50%. So let's go ahead and calculate D here. D is going to equal to 1, 2, negative 5, 2, negative 6, 0, 0, 1, negative 1. D sub x is going to equal to this thing up here, except for with 22, 4, 4 in it. 2, negative 6, 1, negative 5, 0, negative 1. D sub y is going to equal to 1, 2, 0, 22, 4, 4, negative 5, 0, 1. And D sub z is equal to 1, 2, 0, 2, negative 6, 1, 22, 4, 4. Let's calculate D together here. Rewrite 1, 2, 0, 2, negative 6, 1. Zero plus 0 plus a negative 4 minus 6 plus 0 minus 10. It's going to be negative 4 minus a minus 4. It's going to be 0. So we don't just stop at this point. We just know that we don't have to calculate everything, or maybe we do. So this is going to be 0. This means, remember, we either have no solutions or infinite number of solutions. If all of these three come out to be 0, then that's whenever I say infinite number of solutions. So if I calculate this and I get a 0, then I have to keep going. If I calculate this and I get a 0, I have to keep going. And then if this one comes out to be a 0, then I'd say infinite number of solutions. If at any point one of these comes out to be a number, I can just stop right there and then say there's going to be no solutions. So I'm going to go ahead and start calculating these, and I'll let you catch up once I get to there. Calculate the first one, and I got 0, which means I'm going to need to go ahead and calculate this next one. Calculate the next one, and again I got 0, so I'm just going to go ahead and need to go to the third one. I got 0 on this one as well. Since all three of these came out to be 0, and the denominator is 0, I'm going to say infinite number of solutions. Alright, so again, I finished half your homework for you. Please make sure you copy this work onto yours, so that way you can actually hopefully follow it later. But feel free to watch this again as needed. Good luck, guys.